Bismillahirrahmanirrahim. Assalamu alaikum. I'm Dr. Fawad, Assistant Professor at the Department of Physics KUST. Today I'm here with online lecture number 1st of the course Data Analysis Techniques. The course code is PHY293. Today's topic is errors. So let's start it. The outlines of today's lecture is introduction to errors. Then we will discuss sources and causes of errors. And at the end we will solve few examples calculating errors in the data. Definition of error. It is in fact the lack of accuracy in the data. It means that if a data which we calculate experimentally or which we obtain experimentally is less accurate, it means it has got more error and vice versa. So the measurement of accuracy can tell us about how much error we have got in our values that we have experimentally obtained or which we have got through calculation. Excuse me. The second definition is the deviation of the measured result from its actual one. So if we are going to measure a known value experimentally and we measure a different value than what actual value is, so it means we have got some error in our value. So the difference between our experimental result and the actual result gives us the error in our data. Similarly, according to third definition of error, the uncertainty in the experimental data is also called error. So error is whenever we measure a physical quantity experimentally, most of the times we will come across error in the measurement process. If an experimenter knew the error, he or she would correct it and it would be no longer be an error. We should focus on to understand the nature of errors and their sources in measurement. So hence error is caused due to some mistakes done, like mistaking chance effects or spurious correlations for genuine correlations or regularities. Similarly, mistakes about the quantity or value of a parameter, and similarly mistakes about a causal factor and mistakes about experimental assumptions that we have done. So let us solve a few examples calculating errors in the data. Example 1 states that a set of independent voltage measurements taken by 4 observers was recorded as 117.02 volt, 117.11 volt, 117.08 volt and 117.03 volt. Calculate number 1 the average voltage, number 2 the range of error. So the solution to this example 1 is that first of all we have to calculate the average voltage of these 4 values of 4 observers. So for calculating average voltage we will simply take the arithmetic mean of all these 4 and then divide it with total number of observations made. So here are those 4 values, divided it by 4 and we will get 117.06 volt. So that is average voltage. Now the second one is range of errors. So range is in fact the difference between the measured value and the average value. So what we have obtained, it is we have to find the range in two parts, the upper range and the lower range. This is the upper range, which is the difference between the average value and the maximum value in these four values. So the maximum value in these four values is 117.11 volt. This is the highest value out of these four. So we will get that maximum value and take its difference with the average value of all these four, and we will get 0.05 volt. Similarly, for the minimum range of error, we will take the difference of the average value and the minimum value of these four values. So we will get the difference of these two equal to 0.04 volt. So we have got these two values, the upper range error and the lower range error. Now let's take the average of these two ranges of errors, and that would be this plus this dividing by 2, and we will get plus minus 0.045. Rounding off this value, and we will get plus minus 0.05 volt, and that in fact gives us the range of error. Let us move towards example number 2, which states that we have two resistors R1 and R2 are connected in series. Individual resistance measurements using a Wheatstone bridge give R1 equal to 18.7 and R2 equal to 3.624 volts, ohms. Calculate the total resistance to the appropriate number of significant digits. So we have to calculate the significant figures in our result obtained from these two data. So R1, which is given, it has got 3 significant figures. R2, which is given, it has got 4 significant figures. And as we have to find the total resistance or the equivalent resistance of this whole circuit in which we have got two resistances. So for series combination of resistors, we have to simply add up these two resistances, and we will get 22.324 ohms. It has got 5 significant figures, but remember that whenever we add two numbers and both have got different number of significant figures, so the result which we will obtain will be having lesser number of significant figures equal to the lesser number of significant figures in these two numbers. So like here we have only 3 significant figures in this one, it has got 4 significant figures, so the result which here we are getting visibly, we get 5 significant figures, but that is not true. It cannot have more number of significant figures than the least significant number, and that is 3. So it would be having 3 significant figures, so we have rounded off this result to our 3 significant figures, and the result is 22.3 ohms. So that's all for today's lecture. Thank you.